I'm Samantha Black, Editor-in-Chief of Science Board, and I'm here at SLAS 2022 in Boston, Massachusetts. I have Sridhar Iyengar, who is CEO of Elemental Machines with me. Thanks for joining us, Sridhar.
Sure. There's a new emerging field that is called lab ops, or laboratory operations. And there's a really good analogy with how today's lab managers are going to evolve into tomorrow's lab ops engineers. And that analogy we can see in the software world. The last 10, 15 years, you had folks that were traditionally called systems administrators that have now evolved into this field called developer operations, or DevOps. And really what lab ops is about is you have the scientists who are the creators. They're the ones who invent and create things. But then you have this industry that supports them. And today they're lab managers, but tomorrow they'll be lab ops engineers. In the software world, you had a very similar situation where the coders and developers were the creators, and the sysadmins were the ones who supported built all the infrastructure so that they could do their craft. But with the advent of the cloud and over the last decade, sysadmins became DevOps engineers. And we see the same thing with lab managers becoming lab ops engineers down the road. Yeah, that's a good question, because you have a wide array of adoption in terms of data maturity. You have companies that are in the very early stage of just figuring out how to collect data. Maybe most of it's written down, it's in Excel, not a thumb drive. And you have folks on the other end of the spectrum where every purchasing decision they make for an asset or a piece of software or whatever is driven by the question, can we automate data extraction, and can we put it all in one place, and how's information security? So you got this whole spectrum, and there are different types of companies that fit into the spectrum. So one of the things that we've seen over and over and over again is this move towards artificial intelligence and machine learning, and really there's a new generation of startups that are really looking at how do we harness the power of machine learning to discover new drugs, new therapies, and whatnot. And what we've seen is that these companies, because they have no legacy infrastructure, they can start on day one with a data-first approach to how they structure their science. And there's a cohort within this whole sort of life sciences world where this is very, very evident, and that's the group of companies that are generally referred to as the synthetic biology companies. And we have great examples like Ginkgo Bioworks here in Boston and Zymergen on the West Coast. And these are companies that are using AI and machine learning and automation as the first foundation on top of which they build their science. So that's really been the catalyst. So the funny thing is there aren't really a lot of standards. that's part of the problem. And a few years ago, I was in the medical device world, in the healthcare world, and we saw the same challenge in that world where there was a lot of paper medical records, and the transition to electronic medical records was a big deal. If you remember, there was a lot of government subsidies and incentives to kind of do that digital transformation. The challenge here, though, in the scientific and lab ops world, is that there are no standards yet. There's a couple of groups like the Pistoia Alliance or Allotrope that are putting together industry standards for data communication. But overall, you have a lot of siloed data sources. You have a lot of individual vendors, people who make machines and instruments, and they all have their own proprietary standard. That's going to change, but the main challenge here is getting everyone on the same page. So there really aren't universally adopted standards yet, but there are industry groups that are working towards that. Yeah, and so the funny observation here is I can answer this by pointing to the world of electronic lab notebooks and laboratory information management systems, ELNs and LIMS. The reason why there are hundreds, if not thousands, of different ELNs and LIMS is that people who do research, they do different things. When you're dealing with maybe animals in a vivarium and doing animal studies, your needs are very different than if you're trying to change the DNA in a bacterial cell. And so the nature of science is so heterogeneous that I think you're probably not going to have one universal standard, but what you will have is interoperability, so that you have different standards, but they can talk to each other. And that's what we've seen in the medical world, in the electronic medical records world, is that interoperability is key, and you're going to get that by really not having one solution for everything, but just agreeing on how different things will talk to each other. So that's probably the best way I can answer that. So one of the things that we've seen for adoption of digital technologies into science and R&D is the ability for lab managers and lab ops folks to show concrete ROI on the investments that they make. It kind of makes intuitive sense that, yeah, if you do these good practices, you invest here, you'll move science faster. But it's very hard to say, well, I invested $1 here and somebody invented a drug 3 years earlier. But that's the key that we need to do, is to show ROI. And where we've seen that adoption across the board is on the facilities management, the compliance, and purchasing sides. So anything that where it's a dollar amount, if you can show that you have data-driven decisions and you've extracted this data based on utilization of assets and XYZ, it gets executive management bought in very, very quickly. And so we're seeing that for digital transformations to happen, you got to tie that back into some of the more routine, like operational sides of how science is done.